Welcome to CodeRage 7. My name is Pawel Glowacki and this is FireMonkey 3D programming session in RAD Studio XE3. I'm a technical lead for Embarcadero for Delphi and RAD Studio in Europe, and you can see my blog here on this slide, where I'm going to post code snippets and demos that I'm going to demonstrate throughout this session on doing FireMonkey 3D programming. The contents of this session is very much demo-oriented, so I'm going to start with two slides explaining the FireMonkey graphics architecture and how it's possible that you can create from one code base, being Delphi or C++, applications that can be natively compiled to different operating systems using different 3D APIs. I'm going to illustrate this by a low-level 3D demo that is a modified version of a demo program that ships with RAD Studio and shows how you can do FireMonkey 3D programming on a low level using shader code, using index buffers and other low-level 3D stuff. That is going to be followed by a demo of a basic interactive 3D app. So I'm going to just do a 101 demo, creating a 3D application, adding some basic components and display some graphics. In this case, 3D rectangle using a new XE3 materials, and also show how you can actually make it interactive so the end user can interact with a 3D world that is displayed by a FireMonkey application. Followed by this entry-level example, I'm going to demonstrate a special demo that I created for a CodeRage 7 session, memory game 3D. So basically going one step further and creating an interactive 3D application with effects and animations and doing some basic logic. After this demo, I'm going to move into explaining some of the special components that comes with FireMonkey 3D, things like lights, camera, how to make a camera show the 3D world from different angles and different directions, and how is the 3D coordinate system in FireMonkey applications organized. The last demo is a special demo also prepared for this CodeRage 7 session called Space Debris, and is based of making use of a special T-model 3D component that make it possible to load arbitrary 3D information and display it within a FireMonkey application. Okay, let's get us started. So FireMonkey is a business application platform that abstracts away the underlying operating system. So you write your code, your application code with C++ or Delphi, you make calls to FireMonkey, use types defined within FireMonkey, and depending on the underlying operating system, your application is going to make different calls. So if you compile your application on Windows, your 3D application is going to take advantage of a direct 3D, the same user application programming interface that Windows games are using. If you create your application for Mac, compile for Mac, your FireMonkey application is going to make calls to OpenGL, and in future it's not part of an XE3, but it's upcoming, the possibility to create from the same code base applications that will be natively mobile applications, and for iOS and Android the 3D APIs are OpenGL ES. So this is going to be possible to create with FireMonkey applications from the same code base, making calls to all the major 3D APIs on the market today. So for XE3, we are going to focus on just desktop applications, both Windows and Mac, making calls in a cross-platform way, so you don't have to really even know to which platform you are going to compile your code is going to be the same. How this is possible? In fact, FireMonkey is abstracting away the underlying graphics pipeline. So your 3D application code is talking to FireMonkey, and FireMonkey, depending on the platform, is talking to the 3D APIs that is actually talking to the graphical processor unit. So part of your FireMonkey application is being executed in the CPU, and another part is actually executed in a graphical processor interface. And with FireMonkey new XE3 material system, you really can run arbitrary pixel shader programs, so both pixel shaders and fragment shaders. So you have full control on the underlying GPU in this way. So this is quite unique architecture. There is nothing like this on the market today, I believe. So how, from the programming perspective, the abstraction is the T-context 3D class. Also, there is a T-context helper that adds some functionality to the T-context 3D. But T-context 3D is an abstract class that encapsulates common graphics operations, and depending on the platform, it's implemented with DirectX 9, DirectX 10, or OpenGL. Okay, let's have a look into the program that we are going to use. So I have to actually, I'm running on Windows 8. And I need to switch to RAD Studio XE3. So this is a Delphi Hello World 3D modified program. So this is actually a modified version of a demo that ships with Delphi XE3 and demonstrates how you can create FireMonkey 3D programs in a low-level fashion. So you can see here that it's quite straightforward program that just creates some vertices and adds them to the vertex buffer. There is an index buffer that you create as well. There is also a custom material. So material in XE3 is basically encapsulation of shader programs that are being executed on a GPU. So all this information is actually sent to the context. So you can see there is an on render event here that is triggered by the timer that will actually call different methods on a context class and basically set some projection matrix and eventually draw some triangles. So the same program, the same low-level code can be compiled for both Windows and Mac. And this is a kind of a style that you can see in other 3D languages and frameworks. So typically in a 3D programming you are busy working with vertex buffers, with index buffers, writing your shader low-level code, but still the benefit even on this example is that you have just one programming model and you can compile for different compilers. So here I have a possibility to compile it as either 32-bit Windows or 64-bit Windows. If I run this application on Windows, I'm now compiling with the Delphi 64-bit compiler, and I have a graphics application that is actually running using Direct 3D. The same application I can actually recompile using a Mac compiler. So if I just select OS X as a target platform or as OS X and click on Run, the same application code will be compiled with a Mac compiler, and it will generate a Mac executable, and you can see that this same application from the same code is now executed as a native Mac application. So this is really a big deal. So let me actually stop this application and go back to Delphi. So in this way, this is actually, if you want to do something custom, something non-standard, you want to implement your own shaders, you can do this way, and this program is a great starting point for doing this. But most of the time, you don't want to go that low level, and you can still do an assembler coding in VCL or on Windows, but typically you want to use a high-level abstractions, different components that come with Delphi or C++ Builder. So that's why we have a number of 3D components that you can use to make your work even easier. So ultimately, those components are also making calls to context 3D, but then quite a lot of work is already done for you and implemented within the component. So FireMonkey components, going from the bottom of this page, you can see there is a T component. So this is a base class for anything that can be installed and manipulated at DesignTime within RAD Studio. The FMX object is a base class for all FireMonkey components, both HD or two-dimensional and 3D. So this class, TFMX object, actually implements some basic functionality that is common to every FireMonkey object. So this is actually support for parenting. So this is very important concept in 3D applications because you really want to know which object is containing which other object, because all contained objects will actually inherit all the 3D transformations like position, scale, rotation. And also FMX object is where the support for animations is introduced. So anything in FireMonkey can be actually animated over time, and it's actually very powerful in 3D applications as well. A little bit higher up in this hierarchy, we have a T-Control 3D. This is a class that actually is a first class that is purely 3D in a FireMonkey framework. So the Control 3D class introduces properties like the position in a 3D space, different transformations like scaling and rotations, and also a possibility for interacting with the user. So this is a control. So you can it has things like on click event, on double click event. So when the user actually can send events to those controls, and we can actually start programming. So there are some direct descendants of a T-Control 3D, like T-Grid 3D and T-Stroke Cube. So these are quite lightweight components that has a visual representations, but does not require any vertices or anything like this. They are purely based on drawing in a 3D space. A little bit higher up in the hierarchy with a T-Shape 3D. So this is a class that introduces support for materials. So material is a new concept in FireMonkey XE3. So this encapsulates support for arbitrary shader programs, and some of the descendants of T-Shape 3D are text 3D, rectangle 3D, path 3D, and ellipse 3D. So extruded shape 3D basically gives them a depth in a 3D space, but still they are quite simple as compared to the components that are derived from T-Custom Mesh. So T-Custom Mesh is a class that is derived from T-Shape 3D and introduces support for mesh data. So those vertices and those indices that you have seen in a previous example are actually encapsulated as a custom mesh, and there is a number of classes that actually implements a T-Custom Mesh. So there is a T-Mesh. It's quite a generic mesh that has this mesh data public, so you can manipulate it in programmatically. But there are also some already made meshes, so like sphere, cylinder, cone, cube, and etc. That you can manipulate in your application. Okay, let's actually switch to. Actually, I'm going to switch back to Delphi. So I'm going to again do my round trip through the new Windows 8 environment and the start page. So it used to be so much easier with Windows 7, but still. And I'm going to actually, I have a simple interactive 3D component pre-built. So let me actually, to save time, actually do it very quickly without going into much detail. So I'm going to actually create a new FireMonkey desktop application in Delphi. Here I have a choice of either an HD or 3D application. So I'm going for a 3D application. In fact, you can easily, I'm going to actually go for a default layout so I can see also the structure view. And this is my 3D world. So in here I have an actually possibility to use some of the 3D scenes components. So these are the components that you have seen on a previous example. So one component that I'm always want to use is a T-light component. So it's a good idea to have a light component somewhere on the form, so your 3D objects are actually visible. It's possible to live without it, but in most of the cases you want to have a light component. And also, normally I would add a camera component to the form, but in fact, if you don't do it, in every form 3D, there is a design camera built in. So to keep this example simple, I'm not going to add an explicit camera component. I'm going to use a built-in design camera that is part of the form 3D. Now I can actually add one of the 3D shapes. So there is a whole hierarchy of different components that I can use. I'm going to actually go for a rectangle 3D. So this is actually a component that you can see, you can manipulate in a 3D space, and it has 3 different material properties. So this is actually quite new in XE3, that you can change the material that you use for different actually faces of your 3D object. In XE2, material was actually embedded in a 3D shape, so that was not very effective. Now we have a separate material components. So I, for example, can go for a light material source, and I can specify some non-standard color, maybe a teal color. So I can actually use this light material source as, for example, something at the back of this rectangle 3D. So I'm going to use this. Also maybe for a shaft, so the sides of this component I'm going to use. You can see that this has changed. And for the front face of this rectangle, I'm going to use a different material source, a texture material source. So you can actually go ahead and load some texture. So I have a number of pictures that I can actually use. These are the stock pictures that comes with okay, I need to go back, that comes with RAD Studio. So I need to be here. So now I have my texture material. Now I can select a rectangle, and for the front face I'm going to use this texture material source. So in this way I can actually display in 3D some I'm going to save it as default, and now my application is actually displaying a rectangle in a rectangle 3D. So that's actually interesting, but okay, I want to do something else with it. I want to actually do some interactivity with it. So the nice thing about FireMonkey is that it's easy to actually add animations, and also those 3D components, they have events, so I can actually respond to things like on-click event. So I can actually maybe add some animations. So maybe I'm going to actually to save a little bit of time. I have already pre-built some of the code here. So just to save on typing, I can just type in this code, so it's actually faster, and you don't have to see how fast I can type. So this code, what it does basically, it takes the rectangle 3D and it calls a number of animate float methods, so passing different parameters. So you can actually see in this in this code, what I'm doing is, depending on the orientation of this rectangle in a 3D space, I'm either rotating it to the back or to the front, and at the same time I'm actually adding a combined animation to bring the rectangle a little bit closer to the user, and then a little bit further back to where it was. So this is actually, if you look at the 3D space here, this is a 3D coordinate system, so to the right the X coordinates are increasing, to the bottom Y coordinates are increasing, and deep into the form the Z coordinates are increasing. So now if I run this program and click on this rectangle, I should see that my rectangle is actually now turning back and forth. So this is actually, if you look and try to compare this functionality to what's available in other frameworks, this is really a high-level programming. I have not spent a lot of time to get a quite sophisticated geometry, and this geometry I can now go ahead, add platform, the OS X platform, and now I can actually compile the same program for Mac, and from the same code base I have a program that is actually not only is actually interactive both on Windows and on Mac from the same code base. So just using the same techniques, I actually implemented a different program. So just now I'm going to actually use a pre-built program. Yes, I'm going to save this guy. I have this memory game. So this is actually, here I have my memory game 3D. So this is a little program that is actually taking the same functionality a little bit further and using the interactivity to implement a memory game. So let's have a look how it actually works. So I'm presented with a new screen. I can actually click on a new game, and I can actually just select one of the tiles. I need to remember where it was, so I can actually go back. So it's I think that was somewhere here. Okay, this is the match. So in this way actually I can go further and try to memorize, oh, this was the match. So in this way it's a simple game that I have implemented just to play with a number of functionality here. So let's have a look at the implementation of this program to understand how it was implemented. So first of all, I have a number of textures. So these textures are actually a stock images that comes with Windows 8, and I have a special generic list to maintain the list of texture material source components. So this is where I load these images. So this could be arbitrary images, and in fact I have a special method here, load images. So this is this code here. So there is a subfolder in my project folder that stores all the images, and basically I could use arbitrary JPEG images. In fact, other formats will work as well. And I'm actually doing a search for all the files with a JPEG extension, and in a while loop until I find the next image, I'm actually looping, so creating the texture material source component on the fly, and basically also creating the bitmap that is property bitmap from the actual file, and I'm adding this as a texture property. And when this texture material source is created, I'm adding the resulting texture material source instance to my generic list. And in this way, I can build a list of textures based on arbitrary JPEG files. Okay, let's go further. So this is actually what's happening in my form create unit. So I'm creating just this instance, and the moment the end user actually clicking on the new game, this is what's happening. So I need to clear the game screen. So actually this is here. I have this dummy component. So dummy component is a general purpose non-visual component that acts as a container for all the other 3D components. So this is very useful and flexible type. And so basically that's how I'm actually clearing the game screen. Just delete all the 3D components that are inside of dummy 1, so all my tiles, and also forcing the viewport 3D to being repainted. In fact, this is actually interesting that this application, if you look at it, it's not really a 3D form. This is a classical HD form, and I have a T-viewport 3D component that works as my view into a 3D world. So this is actually a possibility to combine 2D components. So notice that this is just a 2D panel and 2D button, but all these components here inside of the screen are 3D. I have here a real camera component. So I use not a DesignTime component, but a camera. So if you look into the properties of the camera, when you add a camera on the form, it will be by default 0 at coordinate 0, 0, -5. I actually like to make it -10 to get it closer. So basically what we are doing, we are looking directly into the Z coordinate, and there are two light components here as well to add some light to the screen. I have also two hard-coded light materials. So this is for the side of the every tile and for the shaft of every tile. So these are actually on the form. I don't create them dynamically. Okay, going back to my previous code. So I need to load images. So this is actually what's happening in the load images. Is I'm actually clearing my the load images is already called, but now when I want to display them, I need to randomize them. So the next thing is the call to randomize materials. So what I have here is another variable called matlist that I create in this get randomized materials. I specify how many images I want to have. So if there is 10 images, I will have a list of 20 randomized textures to assign to individual tiles. So this is actually done quite easily. So this is this code here. So I'm creating the material source. I go and add for through the number of tiles I want to create 2 times, and here I do some randomization. So go through all the items in the list and randomly exchange them, so I have a really randomized list. And then basically what I do is create on the fly these rectangle 3D components, making sure that there is a proper parent, which is a dummy 1. I specify the size on the fly. Also I need to make sure that they are organized in a grid, so I'm using the I and J variables to position them accordingly. And I can on the fly actually assign materials. So those 2 materials are hard-coded, and this is from my randomized list. And also I'm assigning the on-click event to my rectangle. So in this moment I have a screen, and everything else is happening in this click event. So basically the sender to this event is the rectangle that is being clicked. I know this is rectangle, so if it is a rectangle, I can typecast it to the rectangle, so I have a reference to rectangle here, and some logic. So basically, if this is depending on a rotation, I can actually find out if it's visible or not. So if it's actually already visible, I do nothing. If it's actually hidden, then I can show it. And if this is the same tile that is visible, so actually what I'm doing here is I'm looking at if it's actually the visible, if it's not nil, so basically there is some other visible tile, then I'm comparing the references to the material source. This is actually quite powerful because at the end these are just references to the material pointers that I can compare. If the pointer is the same, this means that actually I have match, so I can call remove both tiles and make the current visible tile nil. If this is no match, then I just makes the current visible tile hide and make the visible tile R. So this is actually very interesting, is those implementations of actually hiding and showing. So these calls to animate float are really non-blocking asynchronous calls. So this is very something to keep in mind, that when you call to animate float, something will start happening in a separate thread, and this next call will be happening right away, not waiting until this animation will terminate. So something to keep in mind. So this is just the logic behind this application, and it's actually showing that it's really quite straightforward to do sophisticated stuff with FireMonkey, some basic games, if you think about it, with almost no coding. Okay, so there are also some other, let me actually jump and show you this one slide here. There are also special components that you can use, like dummy and camera. So in this actually next example, I'm going to actually play a little bit with a camera, so I can see what kind of possibilities I have here. So this is actually quite a common scenario to use. So I have this Arrows 3D program. So this is actually the program. Also there is a viewport 3D, and I have a certain layout for camera. So maybe first I'm going to run this program to show you what it does. So I have actually an image of different coordinate arrows. So in these arrows, the red arrow is actually the X arrow. So I can actually, using programmatically this track bar, I can change the position of the dummy object that contains all of them. You can see that it's all panoramic or perspective. If I change the Y coordinates, I go down, so the positive Y goes down and minus goes up. If I use the Z, change the Z property, I actually go in. So this is one thing you can, this is very much what I was doing so far, but it's also possible and quite easy to add events to an on-click, on mouse down and on mouse up events, and also to mouse wheel events to change the size of the object. So now notice that if I now move this, it's still going in the right direction. So I'm actually changing the location, but looking from a different perspective to this application. So this is a very typical layout here. So if you look at those different components, what I have here is there are 3 cameras. So still those components are called camera, but only the last camera, the camera Z, is real camera, and it contains light, so it's always pointing from with a camera. But these 2 other components are dummies, so you can still use them as a container. So they are basically representing rotations in different directions. So looking at the source code here, we have actually, this is actually this calls here are quite common. You can actually maybe, let's see more of this. So this is actually a typical pattern for doing the 3D movements around a certain. If you want to do this mouse down and mouse up, you can do this in this way. Is that basically I have a down variable, which is just a point that stores the moment that I actually pressed my mouse, and then when I move the mouse and release it, on mouse move event, I'm keeping this reference to down when I first started to actually press the key, and depending on my move, I'm changing the rotation of both camera X and camera Y, depending on this actual location of X and Y and the first location. So in this way, I have a nice movement up and down. So also what is interesting here is that when I do a mouse wheel, I can change the scale, so I can actually change the position of the camera. So also what is interesting and was added in the XE3 release is a possibility to use this nice operator overload. So notice this is a vector 3D and this is also a vector 3D. In XE2 I would need to call add method. So actually if I go and maybe define, just to make it easy for me to navigate, define a variable of type vt vector 3D and go there, I can actually see that this is now a vector. So one of the things to notice is that it's now in system.types. So this is really a type that belongs to the system. It's not FireMonkey specific. You can easily use it in a VCL applications as well, because it's just a definition of a generic vector 3D class. And notice also there is a number of operator overloads like add, subtract, equal, and also some useful functions like normalize, like scale, and do things like mid vector. So this is very useful, and you can use it also for other things. But this is a pattern that I wanted to show you. You can actually see in the number of different demos. If you want to have an interactive view into a 3D space, you can actually build it in this way, that you have a nested cameras, so two dummies and the camera itself, and then you just code on 3 events, on mouse down, on mouse move, and on mouse up, and you have a interactive 3D view. Okay, so that's time for the last demo. So now I actually have this demo created specially for this event. It's called Space Debris. And in this demo, I'm actually using a model 3D component. So I have actually this. Actually, I have the model 3D component on the form, but it's not being used. All models are actually generated on the fly. So this is my form create event. I have a number of debris to create. So I have a model 3D component created dynamically, make sure that it's part of a dummy, and I'm assigning to it a random location. So this is the code for actually getting the random location. So I have a X and Y and Z is in some range from minus to plus X, max X. The Z is always positive, so these are the sizes. So it's a kind of a cube. When I randomly create those debris, there is a 200 of debris. And I have two different models. So this is ASE, is an ASCII format exported from a 3DS, 3D Studio Max. Yeah, that's depending on some random value, I'm loading one model or another. I'm also giving it a random scale in different directions to make every brick slightly different. So this is actually my code for the model, for the random scale. So it's not 0, but it's in a certain quite small range. And then I'm adding a random animation. So I have because the code is the same, so for every angle I'm actually adding a different animation. So this is actually code is here. So this is actually quite straightforward. I'm creating on the fly the float animation object, making sure that it belongs to this object that I'm passing in. So creating it, passing to the constructor and assigning to the parent. Actually, this is a kind of a mistake. So probably I should add this obj here, but it still works. So probably this is not necessarily core. So I'm going to remove it. So we'll see if it's going to still work. And I'm adding to the object. So this means add as a child. So now when I specify this rotation angle dot x, for example, as a property, when this is already, this animation is a child of this object, this means that this is actually, we are talking about the property of the owning object. And I'm setting some properties. So stop value 360, so there is a start value is by default 0, so we have a full round. There is some random duration, so we will have some randomness in the movement, and it has to be enabled and it has to be looped. So that's actually what we're doing here. And in the last call, I'm actually every timer event, and this is every, I believe, 20 seconds or so. So let's see, a timer every 50 milliseconds, so 20 times per second. I'm actually having this timer event, and basically I'm iterating through all the children of the of this of a dummy component, and the class where the position is introduced is control3D, so I just typecast to this class, and I can actually go ahead and decrease the value of a position z by a certain constant. So I have the illusion that all those elements are actually flying into the camera, and basically when those given control already reaches 0 or is negative, then we are putting it back into a random location. So let's have a look what is the side effect, what is the effect of this application. So I'm now running it. It takes a moment to start because it's quite a lot of those debris to actually load, and this is the end result. And I think that is a nice summary for the possibilities of what you can do with FireMonkey in 3D. So notice we have now the space, there is a camera, and there is a number of model 3D component instances. In fact, there's 200 of them. Every instance has a different random model loaded into it, and it's placed in a random location, and it has some random rotation as well. So you can see that every instance is actually rotating in a different direction and with a different speed. Okay, so that's it for this demonstration. So I'm going to actually now stop this program and move to my final slide. So in this presentation, in this FireMonkey 3D programming in RAD Studio XE3 with Delphi, I have demonstrated what are the capabilities of building cross-platform FireMonkey applications. So with FireMonkey, you can create one code base, being this Delphi or C++, and with FireMonkey you can compile it natively to Windows and to Mac. And depending on the underlying platform, you can take full advantage of the underlying 3D API. So if you compile for Windows, you are using Direct 3D. If you compile for Mac, you're using OpenGL. And you have a freedom. You can do it low level, like in the first demo. So you can be responsible for the geometry for the individual points that are sent to the GPU, and you can author your own shaders, or you can rely on a high-level 3D components that already have this geometry embedded with it, plus additional benefit of being interactive. So it's not just a visualization, but truly interactive form. Okay, I wish you a great CodeRage 7 session and other sessions to be really great, and you will find the source code for these demos on my blog that you can see on this slide. Thank you very much for watching.
So we've got plenty of questions here. You've answered a few of them, but we'll cover some as well. Do you know if there are any models of human anatomy around? And you mentioned the website there, the free3dmodels.com.
Actually, there's quite a lot of 3D information out there in the internet. So there are some free models, there are some commercial models that you can actually buy online. And this link that I put, that's a repository of free models. So if you're really serious about having a high quality model, you should be prepared to spend a little, probably not a very big amount of money, but yeah, there are plenty of them. So in different formats. So it's important to understand that here in FireMonkey, in the T-Model 3D component, we support three most popular file formats. So this is a DAE extension. This is a Collada XML-based format that is very popular for exchanging 3D information. That's also ASE and also OBG. So these are the three formats that the T-Model 3D component supports. So if you're looking for models, you need to actually look for files in this format.
Okay. Where's the demo program using T-Mesh with T-Light material source on OS X? On Windows, I can write it, but it was back on OS X. You were mentioning you were going to...
I saw this question, but I'm not fully understand what this question is about, because there are also in the replies references to 3D tutorials that are part of the RAD Studio XE3 help system. And these applications can easily be compiled to Mac as well. So I have tried it and I know it works. So you can use simple mesh data and use a light material source. So that's working. You can use demos that come with a product.
Okay, great. But you mentioned also in an answer here, I think that you'll blog about some session for...
Yeah, so right now I have actually a few minutes ago, I have uploaded to Code Central all the demos used in this presentation, and also put the blog post with the link to the download. It's not a very big download, but there is these photos that are part of this memory game 3D are quite large, so there's a 4.5 megabyte download. So you can download it right away from my blog.
Fantastic. When I put a layer 3D with Z position of 0 as the child of another layer 3D, the first layer does not receive any mouse messages. Is this a bug or what's going on?
I think it's important to make sure that probably it's not a good idea to put different components at exactly the same coordinates in a 3D space, because then you will not know which components will receive events that are coming from the user. So I would give it a try and maybe change slightly the coordinate, maybe get it to negative Z, because in a 3D coordinate system for FireMonkey, the camera or the observer is actually in the minus Z. So by default, if you add the camera to the form, it's in the 0, 0, -5 coordinate, looking into the positive direction of the Z axis. So I would actually give it a try and try to decrease or make the Z coordinate negative and see if it works. So I hope it helps. So I'm not aware of any bugs in this respect.
Okay. Have the basic shapes, for instance, the 3D cube, been optimized at all? I was wondering why the cube had so many points and triangles. Seems like this would slow it down terribly.
Okay, I see the point. There are actually there are some drawbacks and benefits of using the Objects 3D. So Objects 3D, especially those that are derived from a T-custom mesh, they have this benefit that they have the mesh data, so vertices, all the connections between them are, and the normals are actually hard-coded in the definition of the given object 3D. So there are, you could alternatively provide different coordinates, different for those that are actually hard-coded. So if, for example, in your application you find there are, for example, too many vertices, for example, actually in a cube it's quite straightforward. I have actually not looked into the implementation of the cube 3D in XE3 in detail, but in fact you could go on with just, let me see, 12 triangles to have a cube properly represented. I'm not sure if there are more. I can actually very quickly check and see. So
there's many more. You can actually change the of course you're right. A 3D cube could be done with 12 triangles, obviously, but all the T shapes are based on T mesh. Essentially, they have a T mesh inside of them, and you can set the subdivision properties and those kind of things, and see how many, and set the number of divisions. The reason that they have quite a few triangles by default is that if you wanted to render a texture on them, it will only render a texture on each triangle, so it would break down very quickly if you had a low number of triangles. So therefore they have, so you can turn that up or down. If you're using a T-sphere, for instance, to show the planet Earth, typically you probably want to increase the number of subdivisions that you have so that you get a rounder and smoother surface as well, with more points from your mesh, from your bitmap, your texture.
Yeah, I think that's a good point, and I think a very good reference under CCR Math 3D visualization, when example that it demonstrates how you can work with the mesh data directly. So if the programmer is not happy with the implementation of a given 3D object, it's relatively easy to actually provide a different triangles or different geometry to use.
Yep. How can I get access to the DesignTime Camera? And you mentioned can you use the RTTI?
Yeah, actually, that's if you look at into a definition of the T-form 3D, that's actually where you can go into you can see where it is defined, and using the RTTI, the new RTTI, you can easily get programmatic access to things that are not really exposed as a public or published properties. So I would try to give it to use just RTTI, but to be honest, I don't see a very good reason why to do it if you can just add an explicit camera to the form and change the property of the form and not to use the design camera, and then you can have a full control on the camera itself.
Yeah, that's what I would recommend as well. And it's actually fairly simple to go into the source code and just clone the DesignTime Camera. It's sitting at 0, 0, -20. I forget if it has a rotation around one of the axes.
It does.
A little bit, 10 degrees or something like that. But and then turn off use DesignTime Camera. I always do that. Typically, certainly if you have multiple cameras and multiple views, you will have to do that. So let's see, we are running very close to the next session. Cyprian Popa has put in a lot of references to documentation, which I will push through here in just a couple of minutes. as well. So thank you very much for all those references to the DocWiki documentation. Does DirectX in FireMonkey 2 support shader model 4 like in normal DX10 applications? Do you know?
I'm not sure. I would guess that it supports the level 3, but that's something to verify. I don't want to be caught that I said that it's 4 and it's not 3. It's something to easily to be checked. So basically, we are supporting on Windows. We are supporting DirectX 9 and 10. So the addition on 10 is new for XE3, and on the Mac side we are based on OpenGL. So I'm not sure exactly which number it is, but for sure it's higher than 2 because that's where custom shaders were introduced. So I would say it's probably 3, but I'm just guessing at this moment.
All right. Okay, so with that, thank you very much, Pawel, for that presentation.
Thank you very much, and all the demos are available online on my blog, blogs@embarcadero.com. It's probably on top because I just posted a moment ago.